Hello everyone, welcome to Clash Encoder. So in this video we will see the question that is row with maximum ones. So this is a medium level question and it has been asked in interviews for Amazon and Snapdeal. So let's see the problem statement. Given a boolean 2D array, so boolean means 0 and 1, so it is actually a binary 2D array of n into m dimensions. So n is the rows and m is the columns, where each row is sorted. So we are given a boolean array, that means 0 and 1, and they are also sorted row wise. So find the 0 based index of the first row that has the maximum number of ones. So we have to give the output, that is we have to return the index of the row which has the maximum number of ones. So as you know, we are only given a binary matrix, so there will be only 0 and 1 and they are also sorted. So we have to return the row with the maximum ones. In this input you can see the row with the maximum number of ones is this, so it is second row because we have to return the 0 based indexing, so it will be 0 1 and 2. So this is the second row, so we have to return 2, and here you can see it is 0 0 and 1 1. So this will be the 1 will be our output because the first row has the maximum number of ones. So you can see from here, if we don't have any ones, if we have if we in this array, if we have all the rows as 0 0 0, then we will return -1. You can see we will have to return -1 if there is no row which has maximum number of ones. So the expected time complexity for this problem will be O of n plus 1, that is number of rows plus number of columns, and the space will be O of 1, and constraints also are between 1 to 10 to the power 3 of the size of the row and column, and the elements are between 0 and 1. So let's see how we can approach this question in an interview. So let's see. So the basic approach or the naive approach that you can think about for this problem will be simply counting the number of ones in all rows and returning the row which has the maximum number of ones. So for doing that, we will have to initialize one count variable which will be counting the number of ones in a particular row, and then the max variable that will be the global maximum, and the row variable which we will return the index of the row. So you can see I have initialized three variables that will be count and maximum till now and the row. So we will have to traverse this matrix in a m into n order. That's why the time complexity will be m into n, because we have to traverse it all the rows and all the columns. So you can see for I is equal to 0 to n, so it will be actually the rows. I will be first I will be 0, then the j will keep incrementing. J will be from 0 to m, that will be number of columns. So for this particular row, the c value will be actually 3. You can see 3 ones are there, so it will be 3. So when we count, when we have a 1 value, that means the a of I and j is equal to 1, then we will increment our count. And at the last, when we have traversed this row, then at the next, before going to the next row, actually we will check if our max variable, that was the global maximum, is less than this count variable. So that means if this max variable is less than the count variable, that means we have found a row which has the more number of ones than the maximum variable. So that means we will update it, and the row, that means we don't have to return the maximum number of ones, we have to return the row which has the maximum number of ones. So we will have to maintain a row variable also, which will be the index of the row. So the index we will you can see here, if the max is less than the count, then we will update our max and also the row. So row will be updated to the ith index. You can see here the count will be 3, so max will be 3 at this point. Now when we traverse this row, it will be 2, so count is less than max, so nothing will happen. When we will traverse this row, our count will become 4. So if our count is 4, our max is less than 4. You can see max is less than 4, so we will update our max, and our row variable, which was 1 previously, 0 previously actually, will be updated to second index. So you can see it will be 2. Now when you traverse this row, there is no 1, so count will be 0. So again this will not work, this condition will not we will not enter to this condition, and at the last we will return row. So row will be actually 2 here, because the last row which had the maximum number of ones was 2 here. So therefore the time complexity for this solution will be actually O of n into m, because it will be number of rows into number of columns, because we are traversing whole matrix at least one time, and the space will be just O of 1, because we are not saving any output, we are simply using some variables to save the output. So this solution will be good, but the interviewer will expect you to optimize it further, because in this solution we are not using the sorted property of the rows. So let's see the next solution. So actually the next solution which you can optimize from the first solution only will be, you will simply maintain the count variable, but here what you can do is, for every row, instead of linearly counting the number of ones as it is sorted, you can simply find the first instance of 1 in a particular row using a binary search. If you do that, you can find the using the binary search. If you don't know, you can search on the video also. I have also made a video on that. I will share the link in the description. So you have to find the first instance or the first occurrence of the 1 in every row, and when you find the first occurrence of 1, you will see which index is the smallest. So if here you can see if you find the 1 in this row, so it will be smallest. Actually it will be at the 0th index, you know. So if it is 0 at 0th index, that means all the elements after this particular index are 1. So that means this row will have the maximum number of 1s. So this is what the binary search approach will be looking like. So it will be actually not optimal. I will explain you the more optimal solutions. So the time complexity for this will be O of n, because we have to traverse all the rows, and log of n, because we are for every row it is sorted, so we are finding the first instance of the 1. So it will be using binary search. So binary search complexity is log of m. So log of n actually. So we have a number of row columns as m, so it will log of m. The space will be again O of n. So this will be actually the optimized version. You can tell this also to the interviewer, then you can think for the most optimal or more optimal solution than this. So actually that will be, as you know, we are given the sorted matrix. Okay, we are given the sorted matrix and we have to find the row with the maximum number of 1s. And if you see here carefully in this matrix, if you see here, we were traversing all the all the columns and all the rows for finding the maximum number of 1s, or the row which has a maximum number of 1s. But if you see here, if we find the first row which has a maximum number of 1s, like if you see if 1 occur at this index, so that means this array, this row is sorted, so all the elements after this one will be 1 only. So if you find the first occurrence of 1 actually in a row, if you find the first occurrence of 1, so you will get the row that is the maximum, that has the maximum number of 1s. So actually what I'm telling is, if you traverse the matrix in this order, actually in this order, you can see in this order, if you traverse the matrix, that is 0, 1 and 1, if you get a 1 at this index, you can see if you get a 1 at this index, so that means this row has the maximum number of 1s. Because you can see after, if this one occurs at this point, so that means all the elements after this one will be 1 only. So all the other rows have 0 at this index, so they don't have one that number of 1s like this row. So actually what I'm telling you is, we will in this matrix, okay, we will traverse our matrix as in this order. Actually we will traverse from 0. Okay, we will traverse from 0. When we will get the 1, you can see we got the 1, so we will simply return that row. So this will be actually traversing using the columns first actually. So what we will doing is, our column variable will increment remain same, that is 0, and our row will keep incrementing. So we will be traversing our rows first, and in which row we will get, if our column is 0, okay, and we get any 0 any 1 at the particular row, we will simply return that row. So that will be the most number of 1s, row having the most number of 1s. So you can see this is the pseudocode for the same approach. Let's see. So you can see first we will traverse the rows. So first for loop will be traversing the column, first will be traversing the columns. So column will be from 0 to m, so it will be actually, the column will remain constant for the first loop, so it will be 0, and we will be iterating over the rows. So rows will be from 0 to n, so this will be 0 to n. So we'll be traversing the rows, and we will check if a particular row array of, you can see matrix or array of row column is equal to 1. So we are traversing in this order, so it will be traversing from top to down, and then again from top to down. When if we don't get 1 in this, we will get at least 1 in this, or otherwise in this. So wherever we find the 1, we will simply return the row. You can see we will simply return the row. If this loop ends, okay, this loop ends, that means we have not found any 1 index. So that means in this question, as it is written in this problem statement, if we have no row with a number of 1s, so we will simply return -1. So at last we will return -1. That means we have not found any row which has maximum number of 1s, or which have at least one number of 1 also. So there is a array, or this matrix with all zeros, so there is no 1. So this solution will actually take O of n plus m time in good, or you can see average case complexity. But in worst case complexity, in this, if we traverse whole this loop, so it will be actually again m into n, if we don't have any 1 in this particular matrix. So it will be traversing all the rows and all the columns. So this solution will take again m into n time complexity. So I hope I was able to explain you this solution actually. So let's I will again give you a brief summary about this solution. So actually, if you traverse this matrix instead of traversing whole matrix, if we traverse the matrix in top to down order, you can see if top to down order, and we get a 1 at a particular index, if we got 1 at this index, so we will be sure that this is our output, because after this index all the elements will be 1 only. So this row will have the maximum number of 1s, as you can see here also. Here 0 was here, so that means no 1 is here. So that means maybe after this 0, 1 will be there. So but here we have got the 1, so that means we have got the row with the maximum number of 1s. So this approach was the optimal approach. You can tell this to interviewer and he will be happier. But let's see the more optimal approach, or actually similar approach. Let's see it. So this approach will be actually like the traversing will traverse it differently. So it will be actually a ladder approach, you can say, or a step approach. So for this approach we will like first of all count the number of ones for this row, actually the numbers of one for the first row. So for the first row, number of ones here are 3, so you know they are 3. So actually we will be simply checking if the next row has a number of ones greater than 3 or not. So instead of checking or counting all the number of ones in this row, what we can do is we can simply check this index, if this index is 1 or not. If this index in the next row is not 1, that means this we have the output as 3. So if there was a 1 instead of 0, so the output would be 3 only, because here it is 0. So we will simply check if the next row has a more number of ones in the previous row or not. If in this row, okay, the answer is 3 only. Now when we come to this row, we are not checking for these ones, because we know, we are sure that we have output of length 3 at least. So that means we will have to check the index before this index, okay. So it will be this index. So if this index is 1, so that means our previous was 3, so now next will be 4. So that means we have 4 number of ones. So that means this has the maximum number of ones. When you traverse the next row, so there is no element that is before this, so our output is 4 only. So the maximum number of ones for the particular row is 4, so our output will be 2 for this particular matrix. So actually I will explain in the code also. So let's see again also in this example, if we have let me change this. So if we have this 0, okay, and this 0, okay, let's see in this input. But first we will traverse this matrix, the first row of the matrix. So our output will be actually 3. We know that there are 2 ones, okay. So this row will be our output, the like starting output. So then when we traverse to the next row, we will not check these indices, because we know we have at least the output which is which has the one number two ones. So we will check for this index. So actually you can see we are going in the stepwise order. You can see we're going in a stepwise order. So we'll check this index. So if you check this index, it is 0. So that means we have 0 2 as output. So it will be remaining 2 only, because these are also 2 ones and these are also 2 ones, so nothing will change. So when you go to the next row, you will again check this index. So if you check this is 1, so that means this will increment, okay, this will increment. So that means we have got a row with more number of ones than the previous row. So we will update our result, and when we go to the next row, we can check it. If we check this row, so it has 0, so that means we don't have any 1 here. So it will be output will be 3 only, because here if we had 0 here, or if we had like 0 here only, you can see 0 is here. If we have 1 here, so it will remain as it is only. The output will remain 3 only, because this is also 3 and this will also remain 3. So our output will be 3 only. So this approach will also take n of m time complexity, m plus n time complexity. I will explain you how. So let's see. So as you know, we are traversing the stepwise order. So we will at most we will traverse m, okay, we will traverse m, that is a number of rows we are going down, okay, we are going one step down, and the number of columns we are traversing will be o of m only, because we are checking this, okay, like this you can see. So our time complexity will be m of m plus n, that will be number of rows plus number of columns, because we are going one step down and one step like backwards. So that will be of time complexity. And our space complexity will be o of 1 only, because we are not using any space to store anything, we are simply storing the variables. So let's see the code. So first I will explain you the code for the first optimal solution that we saw, that was using the this first approach that we saw. The first approach was traversing in this order, okay, top to down order. So let's see the code for this. So the first thing, we will have to initialize a result as -1, because if we don't get any 0, okay, if we don't get any 1 in any row, so we will simply return result that will be -1, or you can simply return -1 here. So let's see. So you can see first we will traverse like row in the column wise order. So first loop will be for the columns, you can see, and the second loop will be for the rows, and we will check if the particular row column is equal to 1. If this is equal to 1, because we are traversing in a top to down top to down order. So if we get a 1 in a particular row, that will be our output simply. So you can simply return the row, and let's see, submit the solution. So let's see. So this solution will be the most easier and the faster, but let's see. I will explain you the second approach also as I explained you. So you can see it took just 0.16 seconds. So let's see the second approach also. So let me comment it. So yeah. So this will be the second approach. This is also similar. So I will also share the code in the description. So let's see. So in this approach, what we were doing is we were counting the number of ones in the first row actually. let me erase this. So we were counting the number of ones in the first row. Okay, so for counting that, you can see first we will initialize j is equal to m minus 1. So will j will be initialized to this index, okay, m minus 1, and we will traverse this in a backward order. So while j is greater than 0 and array of 0 and j is equal to 1. So while it is equal to 1, so j will keep decrementing. So j will reach here, okay, j will reach at this point. So j will reach at this point. Now we have the row initialized as 0. That will be our starting output. So it can be the row 0. So now we will traverse this matrix from the first row. Actually, the second row, you can say the first row using the 0 based indexing. So it will be starting traversing from this row. So we will be traversing from the left to right, right to left, that is this side. And now you can see, let me minimize this. So you can see in this row we are starting from the first row. In this loop we are starting from the first row. As you can see, first row we are starting, and here we will check. We have the j, so we will check while j, so let me change this. So you can see while j is greater than 0, that means we are traversing from right to left. So we will have to check for the j is greater than 0, and array of e of ij is equal to 1. In this it will change nothing, because here you can see it is 0. So j will not decrement, j will remain here only at this point. So it will not do anything. When we come to this index, so I will increment. Here you can see I will increment, this will be skipped first of all. Now I will be 2. Now I is 2. So now if you check, while we will be checking, so while j is equal to this, a of I and j is equal to 1, so it is 1. So yes, it is true. So now that means we have found a row which has more number of ones than the previous row. So we will simply increment or update this row to the ith index, and we will decrement j. So now j will come here. Let me erase this all mess. So yeah, so j will come here at this point. Now we will be checking for the more like previous column for the j. If it is 1, that means we have found the more output, more new output than this previous row. So let's see. So you can see it will keep like decrementing. This j will decrementing, keep decrementing, and I will increment. So when we come to this row, so there will be no j for which the a of ij is equal to 1. So that means our output of ours 3 only. So at the last, as I told you, we will have to check also for the number of actually if our row has all the zeros instead of ones. So for that we will have to check if j is equal to m minus 1. That means if j didn't decrement only, j was here only. If all the elements were 0, so j will not decrement. So that means you will have to check for this condition also. If all the this elements in the matrix are the 0, so if they are 0, j will not decrement. So j will remain at m minus 1. So we'll check if it is equal to m minus 1, we will return minus 1. That means no one is there in the matrix. Otherwise we will return the row that we found. So let's submit the solution. So you can see it submitting. So I hope you got the solution. So guys, do like this video and subscribe this channel for more such videos, and do comment down if you don't understand anything or you have doubt. I will probably answer you in some minutes only. So let's see. So it is submitting actually. So yeah, just taking time. So you can see this solution got submitted, but it took more time than the previous solution that we were using. So you can see it took 0.24 second. The previous solution took only 0.16 second. So I hope you like this video guys, and do like this video and subscribe the channel for more such videos. Thank you for watching.